So today we are going to prove Euler identity without the help of Taylor series. So firstly, I want to ask you sorry for the camera movement you are going to face. I don't have a fixed camera holder that I will buy soon. So let's do this. So we have a function like this. We choose a function like this, and now we will do the derivative on this function. So for the first term, we do the derivative and we get, and this term will be fixed. And for the next term, for this term, this portion will be fixed. So you know the derivative of cos theta is minus sine theta, and for sine it's cos theta. So now we will take ei theta common. So now we know the term I, which is the imaginary number, and the value is root over minus 1. So if we multiply two imaginary number I, we will get this, and if we multiply these two number, we will get minus 1. So as you can see that we have two I, so if we multiply them, I will get minus 1, and as we have minus 1 here, so this is going to be plus sine theta. So now as you can see that this and this term will be, they all neutralize themselves and we get 0 out of this. So if we multiply this with 0, we will get 0. So the value of f dash theta is 0. And as we know that if we get 0 from a derivation, that means that the function is a constant function. So f theta is a constant. Let's take an arbitrary constant k for all value of theta. So now we have to find the value of k. So let's put 0 in this function and let's see what we find. So now if we put 0 in this function, we'll get, if I put 0 here, it will be 0, and we'll get cos 0 plus I sine 0. So as you know that the sine 0 is 0 and the value of cos 0 is minus 1. So f0 is, give me a second, sorry, the value of cos 0 is 1. So as you can see, this term is going to be 1 and this is 0, so we will get f0 is equal to 0, which is, as we previously said, that for k is going to be constant for the all value of theta. So this is the value of k. So we can write that. So we can write e minus I theta cos theta plus I sine theta is equal to 1. So now if we do this, if we take this number here, we'll get 1 divided by ei theta. So as you know that if we inverse this, we will get cos theta I sin theta. If we inverse this, then this minus will be plus. So this is the Euler equation. Now if we put pi, if we plug pi in the place of theta, we will get cos pi I sin pi e I pi. So now e I pi is equal to, we know that the value of cos pi is -1 and sin pi is 0. So now this is going to be e I pi plus 1 is equal to 0. This is the Euler identity. This is the most beautiful equation we ever have. We have Euler number, we have imaginary number iota, and we have pi, and we have one multiplicative identity, and another is additive identity. That means if you add any number with 0, you will get the same number. If you multiply any number with 1, you will get the same number. So this is a beautiful equation.